Welcome back. We continue our chapter on Earth cycles. In this video lesson, we'll talk about conservation cycles. We will see that all matter above and beneath the Earth's surface moves in cycles. Previously, we talked about the first law of thermodynamics, which tells us that there is a constant amount of energy in an isolated system. Well, it turns out the Earth is not really an isolated system, it's an open system, so we have to modify that a little bit, which we will. But also we have the conservation of matter principle. Matter cannot be created nor destroyed, but it cycles. What are some of the driving forces that apply to our planet? And I'm talking about the entire planet. Well, a significant one, of course, is solar energy that impinges upon the Earth. We also have the internal energy of the Earth, that is residual heat, plus energy that is released due to nuclear decay reactions, which occur within the Earth's core and mantle. There's also kinetic energy associated with the rotation of the Earth around its axis. And there sometimes are changes in this precession axis, which we'll talk about at some point. The Earth is also influenced by gravitational pull from other celestial bodies, primarily the Sun, to a lesser extent the Moon and other planets. And of course there are physical and chemical forces that apply to planet Earth. Let's talk about the Earth's energy budget. Let's consider the solar energy that impinges upon planet Earth and what happens to this energy. In this diagram, if we consider 100% or all of the solar energy that impinges upon the Earth, what happens to this energy? It turns out that part of this energy is reflected immediately by the atmosphere and then reflected by clouds and then reflected by the Earth's surface, reflected as visible and ultraviolet light. About 50% of the solar energy is then absorbed by the land and by the oceans. And you don't need to keep up with all of these numbers and all of these processes, but the point is that visible and ultraviolet light that impinges upon the Earth is re-radiated out as infrared radiation. Now, infrared radiation is at a longer wavelength than the visible and ultraviolet light. But essentially, the Earth's energy budget balances out. That is, you have ultraviolet and visible light coming in and infrared radiation going out. And only a very small amount of this energy is actually used to drive things like weather and things like photosynthesis and our solar voltaic panels. So do we have an estimate of how much solar energy actually strikes planet Earth in 1 year? Well, that estimate is about 4 times 10 to the 21st kilojoules. A very, very large number, 4 times 10 to the 21st kilojoules. By comparison, from all energy sources, mankind consumes approximately 5 times 10 to the 17th kilojoules of energy to drive all of our heating and cooling and all of our automobiles and all of our manufacturing, etc. So mankind's total energy consumption is only a very small fraction, 0.01% of the available solar energy that impinges upon the Earth. So you can see why some proponents of solar energy point to the very vast resources of solar energy that are available. In small amounts of this solar energy that impinges upon the Earth are also used to drive photosynthesis to produce biomass, that is, plant life. So the solar energy, visible and ultraviolet light, that impinges upon the Earth is absorbed and is re-irradiated out as infrared, and in the process it keeps us warm. In addition to the continuous heating of the Earth, the thermal energy from the sun that is absorbed by the Earth's crust also produces or leads to convection. That is, if you remember, convection is the movement of masses. That is, masses rise when they become warmer. Hot air rises, hot liquids rise, and cooler masses sink. And this convection can be convection of ocean waters producing ocean currents, convection of the air producing wind patterns, convection of magma in the Earth's mantle producing movements of tectonic plates, volcanoes, earthquakes, the latter being fueled by residual thermal energy in the Earth's core and the energy released through radioactive decay. The movement of air and water, including evaporation and condensation, rain, results in what we will describe as the water cycle, which will be the subject of our next video lesson. So we'll pause, have a brief quiz, and then continue on with the water cycle.